Space is vast, dark, and mysterious. But amidst the emptiness, there are these incredible balls of light, these cosmic furnaces we call stars. They are the building blocks of galaxies, the engines that create the elements essential for life. Stars are not just beautiful points of light in our night sky, they are crucial to our very existence. Stars are like giant nuclear reactors, constantly churning and burning, releasing unimaginable amounts of energy. This energy, in the form of light and heat, travels vast distances, reaching us here on Earth and beyond. Without stars, there would be no life, no planets, no warmth in the vast coldness of space. Stars might seem eternal, but they have a life cycle just like us. They are born, they live, and they die. Their birthplace is a cosmic cloud of gas and dust called a nebula. Nebulae are like giant interstellar nurseries filled with the raw materials needed to create stars. Imagine a cloud of gas and dust, so vast it would take light years to cross. Gravity, the architect of the universe, slowly draws this cloud together. As the cloud collapses, it spins faster and faster like a spinning top, getting hotter and denser in the center. This hot, dense core is the seed of a star. When the core of this collapsing cloud reaches a critical temperature and pressure, something incredible happens: nuclear fusion. Think of it like lighting a match, except on a cosmic scale. Hydrogen atoms, the simplest and most abundant element in the universe, are forced together under immense pressure and heat, fusing to form helium. This fusion process releases an incredible amount of energy, like a giant controlled hydrogen bomb. This energy pushes outwards, counteracting the inward pull of gravity. A delicate balance is struck, and a star is born, shining brightly for millions, even billions of years. Stars, like humans, experience aging. As a star gets older, it starts to run out of hydrogen fuel in its core. The outward pressure from fusion lessens, and gravity starts to win the battle. The core contracts, becoming even hotter and denser. This causes the outer layers of the star to expand dramatically, turning it into a red giant. Imagine our Sun transformed into a red giant, its surface extending beyond the orbit of Mars, engulfing the inner planets, including Earth. Thankfully, this dramatic event is billions of years in the future. Section 5. Fade to white, the afterlife of small stars. For smaller stars like our Sun, the red giant phase is the beginning of the end. As the star exhausts its hydrogen fuel, it expands dramatically, becoming a red giant. This phase is marked by the star's outer layers swelling and cooling, giving it a reddish appearance. The core contracts and heats up, while the outer layers are pushed outward. The outer layers of the star are eventually shed, drifting off into space as a beautiful, glowing cloud called a planetary nebula. This process is both violent and mesmerizing, as the star's outer material is ejected into space, creating intricate and colorful patterns. These nebulae can be observed with telescopes, offering a glimpse into the final stages of stellar evolution. The core, now extremely hot and dense, remains as a white dwarf. This remnant is incredibly compact, with a mass comparable to the Sun, but a volume similar to Earth. The white dwarf is composed mostly of electron-degenerate matter, making it one of the densest forms of matter in the universe. White dwarfs are the remnants of stellar cores, incredibly dense objects about the size of Earth but with a mass comparable to the Sun. Despite their small size, they contain a significant amount of mass, leading to a strong gravitational pull. This gravity is so intense that a teaspoon of white dwarf material would weigh tons on Earth. They slowly cool over billions of years, eventually fading away into darkness. As they cool, they lose their brightness and become black dwarfs, although the universe is not old enough for any black dwarfs to exist yet. This cooling process is incredibly slow, taking longer than the current age of the universe. Our Sun will meet this fate, leaving behind a silent white dwarf as a monument to its former glory. This transformation will take billions of years, but it is an inevitable part of the life cycle of stars. The white dwarf will remain as a testament to the sun's long and luminous history, a quiet end to a once vibrant star. Section 6. When stars explode, the spectacular supernova. But for massive stars much bigger than our sun, the end is far more dramatic. These stellar giants burn through their fuel much faster, and their cores become incredibly hot. Eventually, the core collapses under its own gravity, triggering a cataclysmic explosion called a supernova. Imagine a star suddenly shining brighter than an entire galaxy, releasing more energy in a few seconds than our sun will in its entire lifetime. This is a supernova, a cosmic spectacle visible across the universe. Section 7. Stellar remnants, neutron stars and black holes. After a supernova, the core of the star is left behind, compressed to unimaginable densities. This remnant is the heart of what once was a massive star, now reduced to a fraction of its original size. The process of a supernova is one of the most violent and energetic events in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. If the core is massive enough, it will collapse further, crushing itself into an object with gravity so strong that nothing, not even light, can escape. This collapse happens because the core's gravity overwhelms all other forces, leading to the formation of a singularity, a point of infinite density. The boundary around this singularity is known as the event horizon, beyond which nothing can return. This is a black hole, a region of space-time where gravity reigns supreme. Black holes can vary in size, from stellar mass black holes formed by collapsing stars to supermassive black holes found at the centers of galaxies. These cosmic giants can have masses equivalent to millions or even billions of suns. If the core is not massive enough to form a black hole, it becomes a neutron star. Neutron stars are the remnants of supernova explosions, but they are not massive enough to collapse into black holes. Instead, they become incredibly dense objects composed almost entirely of neutrons. Neutron stars are incredibly dense, packing the mass of the sun into an object just a few miles across. These stars have a crust of atomic nuclei and electrons, but their interiors are made of neutrons, the result of protons and electrons combining under immense pressure. A teaspoonful of neutron star material would weigh billions of tons on Earth. This unimaginable density is due to the fact that neutron stars are essentially giant atomic nuclei, with their matter packed so tightly that a single cubic centimeter can weigh as much as a mountain. These stellar remnants are a testament to the incredible forces at play in the universe. Section 8. Cosmic recycling, the death and rebirth of stars. But the death of a star is not the end. The material blasted out in a supernova, enriched with heavy elements forged in the star's core, seeds the surrounding space. This cosmic recycling process provides the raw materials for new stars, planets, and even life. The iron in our blood, the calcium in our bones, the carbon in our DNA, all were created in the hearts of stars that lived and died long ago. We are, quite literally, stardust. Section 9. Conclusion. The enduring legacy of stars. Stars, those distant suns scattered across the universe, play a vital role in the cosmic drama. They are not just points of light in the night sky, they are the engines of creation and destruction, the forges where elements are born, and the beacons that guide us through the cosmos. They light up the darkness, create the elements essential for life, and shape the galaxies we call home. From the hydrogen and helium in their cores to the heavier elements forged in their fiery hearts, stars are the alchemists of the universe, transforming simple atoms into the building blocks of planets, moons, and even life itself. Their life cycle, from fiery birth to spectacular death, is a testament to the awesome power and beauty of the universe. Stars are born in vast clouds of gas and dust, where gravity pulls material together until nuclear fusion ignites. They live for millions to billions of years, shining brightly and influencing their surroundings. When they die, They do so in dramatic fashion, either gently shedding their outer layers or exploding in a supernova, seeding the cosmos with the elements necessary for new stars and planets. As we gaze up at the night sky, let us remember that we are connected to the stars not just by distance, but by the very essence of our being. The atoms in our bodies were forged in the hearts of ancient stars, making us children of the cosmos. This connection is a reminder of our place in the universe and the shared heritage we have with all matter in existence. Their story is our story, and their legacy will continue to inspire wonder and awe for generations to come. The stars have guided explorers, inspired artists, and sparked the curiosity of scientists. They are a source of endless fascination and a symbol of the infinite possibilities that lie beyond our world. As we continue to explore the cosmos, the enduring legacy of stars will remain a beacon of hope and inspiration, reminding us of the beauty and mystery that surrounds us.